Okay, as we look at our chapter 5, section 5.7, inverse trigonometric functions, you got to remember we're dealing with our integration now. So you can notice that last time in section 5.6 we dealt with dealing with the derivatives of the 6 inverse trigonometric functions, and so you just need to remember that now we're going to be going in the reverse direction. So we've got to match everything up. So you're basically going to have to remember to memorize these integrals. So right here it says the integrals involving inverse trigonometric functions. So you can notice we've got this first one. We've got number 1. It says we've got then it says that we have du all equals a squared, square root of a squared minus u squared, all equals the arc sine of u over a plus c. And then the second one you'll need to memorize this one right here. So it says we have the integral of du of a squared plus u squared equals 1 over a arc tangent of u over a plus c. And then you're going to notice this next one. And it says that we have the integral of du all over u times the square root of u squared minus a squared all over 1 over a arc secant of u, absolute value of u over a plus c. So whenever I do my integrals, and we'll go ahead and just take a look at this first example right here. So example number 1 says we've got this integral right here, and it says this integral is going to be the integral of dx all over the square root of 4 minus x squared. So I'm going to go ahead and take a look at so you're going to notice what I do on this problem, and when I do this problem right here, I want to match up first off and see which one it most closely matches. So the indicator for me is the square root sign in this denominator, and then it's got this constant right here, and that's my indicator, is this constant minus x squared. Now whenever I do that, what I always think of whenever I look at that is I'm looking at my arc sine. And I'm trying to use this little annotator here. It doesn't look like it's working too good, but I'm going to go ahead and just erase this real fast and see if I can write on this screen. It's going to take some practice. But whenever I'm looking at my arc sine, so if you go back to this OneNote right here, you're going to notice the arc sine, that it's, maybe I'll just use my mouse right here, it's always the square root of some constant minus that variable squared. And so what I'm going to do is I'm going to go ahead and figure out, I have to get it to match up. And so I got to figure out what my a is. So notice this is a squared, and then this is u squared right here. And so what I like to do when I'm doing my problems is I will go ahead and let my a squared equal whatever the constant is, and I can see that a is going to equal 2, and then I let u squared equal the equation, so that's going to be my x squared right here. And so when I take the square root of both sides, I get u equals x, and I take the derivative of u equals x, I get du equals dx. So this tells me if everything matches up correctly, and it did. So everything matched up correctly in my equation, and so this is just a straightforward equation that you can just go ahead and find the answer to. And so if you look back at your book, that's what they do. They go ahead and show you that this all matches up perfectly. And so since it all matches up perfectly, it's just actually a matter of substituting it into the equation. So notice here's my u, and so that's just my x. Here's my a, so that is my 2, and that's going to be my plus c. And so that all matched up perfectly, and so that is why that is just the arc sine of x over 2 plus c.